The diagram shows two blocks at rest connected by a light, inextensible string which passes over a smooth pulley. Block A of mass 5 kg rests on a smooth plane of 30 degrees to the horizontal. Block B of mass 10 kg rests on a rough plane inclined at 45 degrees to the horizontal. On either side of the pulley, the string is parallel to the line of the greatest slope of the plane. Block A is on the point of sliding up the plane. Draw a diagram showing all the forces acting on each block. Find the tension in the string and find the coefficient of friction between the rough plane and block B. Okay, so first step is to draw a diagram. So the forces acting on this block, is first of all to point out that this is the smooth plane, will be its weight acting downwards, which is 5G. There will be a normal reaction RA, and then there's the tension in the string. For block B, which is on a rough plane, there will be the tension, there will be the weight acting down 10G, the normal reaction, which we call RB. Make sure you indicate that these are different. Now, as it's on the point of moving, there will be some friction here, because the whole system is going to try to move that way, but it isn't actually moving, it's just on the point of moving, so it's limiting friction. So it is mu RB, and the extra force here. Right, part B is to find the tension in the string. So the easiest thing is to use this block here. And we can say, if we resolve along the plane, then we got T minus the component here of the weight, which is 5G sine of 30 degrees, is equal to 0. And that will give that T is 5G sine 30, which is 24.5 newtons. Right, if we now consider the 10 kg block, so we're now actually on part C. This is a rough plane. Okay, and we've got to find the value of the coefficient of friction, which is mu. So if we first of all resolve this way, okay, resolving this way, we're going to have RB, and then we're going to have this component here of the weight, which is going to be 10G cos of 45 degrees, and that's equal to 0 because it's in equilibrium. That gives that RB is 10G cos 45. You can either work it out at that stage or leave it for the moment. And then if we resolve along the plane, so acting downwards, we're going to have this component of the weight, which is 10G sine 45. And then we're going to take away the friction, which is mu RB, minus the tension, and that's equal to 0 because it's on the point of moving. So we've got 10G sine 45 minus mu, what we need to find, times RB, which is that, minus mu times 10G cos 45 minus the tension, which is 24.5, and that's equal to 0. Writing that out again. So basically, we've just got to find the value of mu here. So I'm going to take all this to the other side. So we're going to have 10G sine 45 minus 24.5 is equal to mu times 10G cos 45. And therefore, mu will be 10G sine 45 minus 24.5 divided by 10G cos 45. On my calculator, that gives me a value of 0.6464, which is 0.646. Okay, this has been a video to show you how to find the coefficient of friction on a connected object. I hope you've understood, and I thank you very much for watching.